Could you guess what the next definition for matrix arithmetic, or excuse me, vector arithmetic is going to be? Yeah. And why don't we start with column vector addition? And then could you guess another definition that I might ask you to extrapolate from this? Row vector addition. And we'll do that as a team. So could you guess what we need for column vector addition? Could you guess? Okay, so yeah, so we say maybe let x and y be an element of Rn, and define addition on these vectors as x plus y. Okay, what do we know about the sizes of each x and y in this definition? How many rows, how many columns? N rows, so this is an n by 1. And then I add that to n by 1.
If you write x and y is element of R to n, how do you know that x is not the row vector and y?
Oh, I'm so happy you asked that.
I've written all over the place and
Yeah. So we're going to get into the idea of popularity contests, I suppose. So this is a side note. I actually have that in my notes, but I didn't say it out loud. This is the first time I've filmed, and I'm still getting my head around what that means. So do you remember when we don't write stuff, but we see it anyways? Okay. So I forget your name. I remember meeting you at least once. Chris. What's this? What's the output of that?
4.
Okay. How did you know that it wasn't this one? I never wrote that that was the square root, right? How did you know that it wasn't the fourth root?
Well, we call it square root.
If we don't write it, that square root is so popular that if we don't write it, what do we see? 2. Okay. So that's an example where we haven't written something, but we've agreed in the community to put our little mathematical decoder rings on and say if we don't write it, we see 2. Okay, here's another one. What's that?
Yeah, base 10.
Are you sure? How come you didn't know that it was base 2? How come it's not base 2? Because we just agree, right? Okay, Rn, the space of column vectors, is so amazingly popular, it's such a powerful space, that if we do not specify the number of columns, normally in all matrices we should always specify the number of columns. There is just one situation where we don't have to do that. What is it? Column vectors. And just like we've agreed previously, for very, very popular functions or for very, very popular applications, there are some instances where I don't have to specify a certain scalar value associated with a particular important concept, and yet we will all agree that that concept is understood. So too, if I write Rn, what does that immediately mean? N rows, 1 columns. How do you know that it's not a row vector? By agreement, yeah. It's literally just an agreement between nerds.
You could say that one is a column vector, but then if you're looking at a row vector and say you couldn't write this is in Rn.
It would be very non-standard in the field to write that. If you wrote Rn, I would immediately assume column vector, and everybody that's had any formal suffering in this field would feel the same way.
Okay.
Yeah. Okay. So here we go. We had a great question, by the way. Yep. Okay, so we had x plus y. This was an n by 1. How big was y? N by 1. Could you guess what the addition between those two vectors ends up being? x1 plus y1, x2 plus y2, all the way down to xn plus yn. How big is that vector? N by 1. And let's just do a quick side note. For one vector-vector addition, how many scalar-scalar additions do we get out? Yeah. For a single vector-vector add, we do n scalar adds. I saw a hand go up. Yeah?
Is it possible to add 2 vectors that are not of the same length? So So if it was like n by 1 and m by 1?
No. That's a great point. These dimensions must be identical for this addition to make sense. If the dimensions are not identical, we don't have an addition operation that's defined on those. Yep. Are we able to add a column and a row vector? Let's answer that from the standpoint. So here's a question. So let's suppose that we add x, which is n by 1, and we try to add that y, which is a 1 by n. What's the rule that we just stated? In order to add matrix vectors, what must be true? The dimensions must be identical. In this situation, what do we say about these two dimensions? They are not identical because the number of columns does not equal the number of rows. Therefore, yeah, dimensions are not identical, no addition possible. It's a very, very easy thing to fix this problem. What would you do to fix this problem? Take the transpose, and we'll talk more about that in a bit. That's a great question. Okay, so the answer is no, we can't add vectors that do not have identical number of columns and rows.